Hey there, everybody. Root Beer here, looking at question number 9 on the Manitoba Math Contest from 2017. Question 9. How many solutions are there to the equation? Oh, this is long. Okay, 123. Okay. X1 squared plus x1, x2 plus x2 squared plus x2, x3 plus x3 squared, and I guess it just keeps going on like that. So we'll get a square, and then, well, in between two squares, we'll get their product, I guess is what's going on. All of that equals 1. And we want solutions in integers. Okay? It should be clear from your work how you know that you have found all solutions. Okay, so they are really wanting justification here. Alright, so we only have one equation to go on. So either there's going to be a whole lot of solutions, like 123. I mean, that's a oddly chosen number. I can't think of any nice properties 123 has. I guess it's 2 more than 11 squared, but I don't think that's really going to help us here. Maybe it's a multiple of 3. I don't know. But, so either there's going to be a lot of solutions or there's probably going to be no solutions. Can we think of a solution? I guess 1 and then everything else being 0 should work. That could be 1 and everything else is 0. So it's entirely possible. But how are we going to show? Because I think, because we do want numerical answers, but as they say at the start, you got to justify everything. So we could probably guess maybe there's only 123 answers. No, I guess 2 times that, because each one of these could be, x1 could be 1 or -1, and everything else is 0. Okay. What are we to do? Well, I'm going to copy down the equation, and I'll tell you what it looks like. Because what's drawing my eye is these squares here, and then the x1, x2 in between them. x3, x4, x4 squared. I don't know. I want to fit it onto the whole page. So plus, and then we'll just keep going, plus x 122 squared plus x 122 123 plus x 123 all squared equals 1. Now, I'm more used to something like 2x1 x2 plus x squared, because if I had that, I could group this and say, well, it's really just x1 x2 all squared. And if I could keep doing something like that, then I'd get sort of a whole bunch of squares equal to 1, but every square would have to be either 0, well, all of them would have to be 0 except for 1 would have to be equal to 1 or -1 in order to get a sum like that. Now, the reason this isn't going to work out is because once I use this x squared for this one, I have no x squared to pair with my, x3 squared, and also, I don't have 2's here. Now, I can fix the 2 problem really quickly by multiplying by 2, and that's going to also have the effect of producing extra squares for me. So, 2x1, actually, I think I'll choose to write it like this. No, we'll write it regular. Plus 2x2 squared. And now there's an x2 squared. One can go here, one can go here. So I think we're on to something here. And that's going to be 2. I'm not going to write in the rest of the stuff right now. But now I can write it as x1 squared plus x1 squared plus 2x1 x2 plus x2 squared. Plus, and then now we group the x2 squared over here. And we have an extra x3 squared, and that will go here. That's equal to 2. And now I can x1 squared plus x1 plus x2 squared plus x2 plus x3 squared. And then eventually it'll go all the way up to 122 plus 123 squared. And then there will be an extra x123 squared over at the end. Okay, now having done that, I ask myself, what did that accomplish? Am I any closer to actually getting solutions? And yes and no. I mean, the reason I did all that is sort of because, the x1, x2 being multiplied together was really nagging at me. That's sitting out there, it's being weird. If it was all just a sum of squares, as I already said, if I have a sum of squares equal to 1, I mean, what's really nice is when you have a sum of squares all equal to 0, all those squares have to be 0. Because remember, a square of an integer, no less, is either 0 or it's positive. You can't add up a whole bunch of positive things and get 0. You'd have to only add up zeros to get 0. And similarly, when you add up a whole bunch of squares and they equal 1, one of those squares has to be 1, the others have to be 0. And now we have a whole bunch of squares adding up to be 2. And the only way that can happen, none of the squares could be, 4. That'd be way too big. You can't take 4 and then add on more squares. You'll only ever increase things. You'll never get down to 2. So two of these expressions now has to be equal to 1 or negative 1. And the rest all have to be 0. So I need to explain that, and then I don't know where I'm going from there. So to have a sum of squares be 2, we must have exactly 2 of the squares are 1, and the rest are 0. And that's the only way it works. And you might want to add a sentence or two justifying that a bit more, but I say it's clear. Okay. Now, if I put a 1 in one of these bigger groups, what does that do? Or do I want to... So the question is, how am I assigning my 1s? Not equal to 0 to equal to 2. Okay, am I picking my 1s by saying, aha, I'm going to let this be 1, and this one down here along the line, that's going to be, these are our 1 squared, so now inside can be either 1 or negative 1. Is that the way to go? In which case then I'm sort of just choosing 2 groups. Well, let's look at a simpler case. Go up to x to the 4. So when in doubt, look at a simpler case. Okay, now could I say something like x1 is 0, x1 plus x2 is 1, x2 plus x3 is 0, x3 plus x4 is negative 1, and x4 is 0? Is that allowed? Is that possible? So we get x2 has to be 1, and then x3 has to be negative 1. So yeah, that works. And then x4 would be 0. But if I make this a 1, I mean, x3 has to be negative 1, so that would make x4 have to be 2, but x4 is 0. So I can't just pick squares, pick expressions that are squared and say, you're 1, you're negative 1, the rest of you are all 0. You're 1, the rest of you are all 0. You're negative 1, the rest of you are all 0. I can't do that. There's sort of a trade-off. So, can't just pick expressions. What if I just pick numbers? So if I just say x1, maybe I can pick expressions. I can pick squares and say, okay, x1 squared, you're going to be a 0, so x1 is 0. x1 and x2, you're going to add up to 1. x2 and x3. And then the only other thing I can say is 1 further down the line isn't 0. Everything else has to be 0. So that's sort of the trouble. I got lucky the first time. So this needs to not be 0. Everything else needs to be 0. So that tells me x to the 3 isn't 0. This tells me x2 is 1. This tells me x3 is negative 1. So now I know this one's going to be negative 1. So it looks like I can choose two squares and pick one value for an xi. That's what it's looking like now, in which case, once I have this gives me 2's and only this will give me 2's, I can then count all this up. Okay. Now, I'm a little worried about the endpoints. Should I be worried about the endpoints? You know what? I don't actually think so. Because I guess what I could do is write this as x0 plus x1 squared. And then all the way up to x4 plus x. Like, introduce an x5 squared. But start out with x0 is always 0 and x5 is always 0. I don't really see that helping a whole lot, but now I can start assigning, I can just choose expressions. So now I don't choose an x1, but I do choose, so choose 2 of our xi plus 1 squareds, and for one of them, we'll say, the lower one. We'll say xi plus 1 is equal to an actual plus or minus 1, and then it'll sort of propagate down the line. Okay. So let's see if that works. And we'll go to the big one. So that was just my experiment. So I'll start by saying let x0 equal x124 equals 0. So now our expression is just all of these. Now I'm back to the actual proof. And how many expressions are there? 1, 2, 3. So it's 124 squares. So now I'm going to say I'll choose 2 of them. And how many ways can that be done? There's lots of expressions. If you're familiar with choose notations, 124 choose 2. Another way to realize this is 124 times 124 minus 1 all over 2. That's another way to count this up. Lots of ways to evaluate this. So 123 times 124 all over 2, or 123 times 62. Okay. So I claim that works, and so I'll have xi plus 1 squared, and equal to I guess it would be, since the way I'm counting them is xi minus 1 plus xi, xj minus 1 plus xj squared. These guys are going to be equal to 1. And then xk minus 1 plus xk squared equals 0 for all other k. This gives a series of equations. Something like x0 plus x1 is equal to 0, x1 plus x2 equal to 0, all the way down to xi minus 1 plus xi is plus or minus 1, all the way down to xj minus 1 plus xj is plus or minus 1, all the way down to x122 plus x123 equals 0, x123 plus x124 equals 0. And of course, the j's and the i's can give us the endpoints. This is just me writing a general one. Okay, now finally I'll make so making a choice here solves all the values of the xk's. For example, if I let these guys be 1, I know x naught is equal to 0 and x124 is equal to 0. So what do I have? So if xi minus 1 plus xi is equal to plus or minus 1, so two choices here. X naught is equal to x1 is equal to everything up to xi minus 1 being equal to 0. And then we'll have xi is plus or minus 1, xi plus 1, because these two have to add up to 0, is minus or plus 1. Xi plus 2 is plus or minus 1, because it has to cancel out with whatever this is. All the way down to xj minus 1, and we'll get to that guy in a moment. Xj is then xj plus 1, xj plus 2, all the way down to x124, which we know is equal to 0. And xj minus 1 is going to be negative 1 to the j minus I times xi. J minus 1 minus I. Okay, and this solves the system. So because there are two choices, once we've made our choices for xi and xj, or once we've made our choices for I and j, two choices, once I and j are picked, from 1 all the way up to 124, the two choices here are between plus or minus 1. We have 2 times 123 times 62, or 123 times 124 different solutions. And calculators aren't allowed. You could probably leave it like that, although I guess we could just multiply this out. This is going to be 123 times 123 plus 1, 123 squared plus 123. I don't know 123 off the top of my head. I'll tell you what, we'll do something else. 120 plus 3 times 120 plus 4. So I'll get 120 squared. That's something I can do. Plus 3 times 120 plus 4 times 120 plus 12. So that's going to be 14400. Plus 7 times 12 is 84 with a 0. Plus 12. I guess we can line them up. 2, carry the, actually no, there's nothing to carry. 4 plus 1 is 5. And then we get 4 plus 8 is 12. Now we've got a 1 to carry. And 1 plus 4, 5 again. And then we get a 1. So we get 15252. And that's going to be our final answer for question number 9. Interesting setup we got here. And we've got one more question, and that will be question number 10. And I will see you guys for that in the next video. Thanks for watching.